Okay, so in today's lesson we're going to look at linear sequences and how we find the nth term of a linear sequence. Just to start off by explaining what exactly a linear sequence is. A linear sequence is a set of numbers that they will go up or down by the same difference each time. Basically it's a pattern with a starting point, and the numbers will either increase or decrease by the same amount each time. Okay, so we'll start with the most basic type of questions that you'll encounter in your exam, and it's simply find the next term in each of the following sequences. So it's easy enough with a linear sequence to spot the pattern. Okay, what you do and what you'll do with any sort of equation involving sequences, always start off by looking at the difference. And the easy thing about the difference with a linear sequence is that it'll go up or down in the same amount. So for example, if I look at this sequence 4, 7, 10, 3, well, first off it's going up, and it's going up by the same amounts. The difference between 4 and 7 is 3, so we're adding 3 each time. Okay, so the next term in this sequence is going to be 13 plus 3, which would be 16. Okay, moving on to the second example, again a linear sequence. All these are linear sequences, and again what you will notice is that it's going up by 2 each time. Okay, so 3, 5, 7, 9, adding 2 each time, add 2 to 9 to get the next term. 9 plus 2 is 11. Okay, also just keep in mind that they can of course go down as well, and that's why we're looking at this example. So 6, 1, minus 4, minus 9. Sometimes be a wee bit trickier to spot with the minus when it goes into the minus numbers, but again it'll be the same difference. So difference between 6 and 1 is minus 5, difference between 1 and minus 4 is minus 5, so we're taking away 5 each time. So the next term, 9 minus 9, sorry, take away 5 is minus 14. Okay, so that's how you continue the sequence when it comes to linear sequences. Just work out the difference and either add or subtract that difference on to find the next term. Our next example, we've been asked to find the 10th term in a sequence. Okay, so again, straightforward enough. And we've got 1, 2, 3, 4, the first 5 terms in this particular sequence, and all you have to do is then continue it on that wee bit further. So the difference between 8 and 11 is 3, so we're going up in 3s each time. So I'll need to add 3 on to keep going. Okay, so 20 plus 3, 23, that's the 6th term. 26, 29, 6th, 7th, 8th, 32 and 35. So 35 is the 10th term in this particular sequence. So as long as we're not going too far into the sequence, it's fairly easy to work that out. Now the next part is the tricky part, where we're going to look at what exactly the nth term is. So the nth term is a formula that you will work out for each of the sequences that allows you to work out any term in the sequence. This would have been, for example, a lot more difficult if I was asked to work out, say, the 100th term. It would take quite a bit of time for me to continue this on another 95 times, and to be quite frank, it would be a waste of your time within the exam. So the nth term is a formula that we can work out for each sequence that allows us to work out very quickly any term within the sequence. So we'll look at a couple of questions where we're asked to find nth term. I'll not try to overcomplicate it, I'll keep it quite simple. It is a formula that involves n representing the term in the sequence that you're trying to find. So say if you're trying to find the 5th term, n would be 5. Say if you're trying to find the 8th term, n would be 8. If you're trying to find the 100th term, n would be 100. So you'll end up with a short expression or a formula. What we're asked for here is find an expression for the nth term in the following sequence. So again, this sequence, looking at the difference, it's going up in 4s each time. Okay, and what will always be the case for finding the nth term, finding this formula, is that the coefficient of n, the number that you would multiply n by, is the difference. So that's why we have to find the difference. So the difference in this case is 4. And if it's going up the way, it's a positive 4. If it was going down the way, this number would be negative. So for this particular sequence, we start off with 4n. Now, there's a number normally that we may add or subtract within the expression or formula, and how we find out what this number is, this is the way I always think about it, is what is added or subtracted from the difference to get the first term. So basically, how do I get from the difference to the first term? Well, if I want to get from 4 to 5, all I'd be doing there is adding 1. So this would simply be 4n plus 1. Okay? And that's what my expression for nth term will be for that, 4n plus 1. Okay? Don't overthink that at this point. I mean, if you're just trying to learn how you write the nth term of a sequence, that's what we do each time. So we always start off, we're going to move on to the next one. So question B of these types of questions, 2, 7, 12, 17. If I want to work out the nth term for that, so we'll start off by writing n. We know the coefficient is going to be the difference, so this sequence is going up in 5s each time. Okay, so it's going to be 5n. And then I have to think, how do I get from 5 to 2? Well, I take away 3. So that's my expression for that nth term, 5n take away 3. Okay? You might be wondering at this point what we use this for. We're going to tackle that in a wee second. Sequence C, so we've got 4, 1, minus 2, minus 3. So we're going down the way this time. So, same sort of thing. We'll start off with n. The coefficient being the difference, well, we're going down, so it's minus 3. So it'll be minus 3n. And then I have to think, how do I get from minus 3 to 4? To get from minus 3 to 4, I need to add 7. You can use a number line to help you if needs be with that type of question. But it's the same thing. So the coefficient, the number beside the n, is the difference. And this second number is what we add or subtract to the difference to get to the first term. All right? I'm going to do one more example. Find the nth term of this particular sequence. Okay, so 4, 10, 16, 22. We're going up the way, so the nth term. So start off writing n. The coefficient of n is the difference. So we're going up in 6s this time. So it's 6n. How do I get from 6 to 4? Well, I take away 2. So it's 6n take away 2. Now, this example shows us what the purpose of this would be. If I was asked the 50th term of this sequence, again, it would be quite tricky, quite awkward to continue this on another 46 times. So what I would do is I substitute, remember n represents the term of the sequence, so if I want to find the 50th term, well, n would equal 50, and I then substitute it into our formula. So 6n minus 2 becomes 6 times 50 minus 2. Okay, 6 times 50 is 300. Take away 2 is 298. So if I was to continue this sequence on another 46 times, I would arrive at 298. And this formula allows me to avoid having to continue it on another 46 times. All right. Nth term, I understand it can be quite difficult grasping the concept of exactly what it is, but finding the nth term itself, just remember this for the formula, and then it's just a basic bit of substitution if you want to find, say, the 100th term or the 200th term within a sequence. I'll put some questions up for you to try, and anything you're unsure about, just ask.